clock, whether you run around the clock or you take the clock around you, whether you possess the power to switch off the clock, doesn't matter. The time never stops. Hello and welcome to Rockcom Infosystems. My name is Raza Sheikh, and today we're going to talk about yarn, yet another resource negotiator. The topic that we're going to take up today is to have a clear understanding of yarn, okay, and then we're going to talk about why do we need yarn, and then take a deep dive into yarn architecture. Finally, we're going to do a replay of what we have discussed. To begin with, yarn basically is a resource management layer within the Hadoop. It was introduced as part of the version 2 of Hadoop, and it actually allows multiple data processing engine to interact with the HDFS data and process it. And also it does the job scheduling. Fine. So I'm giving you a kind of quick visualization of what and where exactly yarn sits. So you have HDFS, which is a redundant reliable storage, and on top of it is what you have, the yarn, the cluster resource management layer. Fine. And on top of yarn basically is the multiple data processing engines possible, like graph, and then you have interactive TAS, and then you have streaming Storm, and then you have MapReduce as the age-old batch processing data processing engine, and then you might have multiple other like Spark for in-memory processing, and online for HBase, and so on and so forth, whatever comes in near future. Okay. The architecture of the yarn is same as what the HDFS architecture is. So it does have the master, and then it have slaves. Fine. Master has its own daemon, and the slave have its own daemon. And daemon is a term that we have already understood in the HDFS architecture walkthrough, but for everyone's benefit, it is a background process that's waiting for the instruction to come, and then it can process the instruction accordingly. Fine. So the master daemon within the yarn architecture is known as a resource manager. It is the one which actually monitors the slaves, as well as it actually distributes the jobs. It is the one which requests the jobs from the client, and so on and so forth. We're going to take the deep dive accordingly. And then the slave daemon within the yarn architecture is known as a node manager. It is the one which actually launches the task, and then it actually reports back its status to the master daemon, which is a resource manager. Moreover, yarn is a collective architecture. What does it mean? So yarn basically is the one which processes the data, fine, but it processes the data if the data is available, fine. And where is the data available within the Hadoop world is in HDFS. So yarn sits in the slave node along with the HDFS data node. Okay, fine. So a quick glance of what we have just discussed. So master and slave architecture, like HDFS, yarn runs on the master and slave node. Yarn master daemon being a resource manager, it actually accepts the jobs, track the resources, and monitor. It also distributes the work accordingly. The slave daemon being node manager, it's the one which launched the task to run on the slave node. Slave node, report the status back to the master, and it is basically HDFS and yarn basically a collective architecture. Slave node runs both HDFS and yarn on the same machine for the betterness, because it is the main purpose, right? You remember the concept of getting the data calculation near to the data rather than taking the data near to the calculation. Okay. Now, why do we need a yarn? So before we understand what exactly yarn is, we have to understand why do we need the yarn. For better understanding why do we need a yarn, we have to actually get into the detail of what exactly the architecture we had earlier, because the resource management layer, if you talk about the resource management, this was something which had been happening with the version 1 of Hadoop as well. But as we know, it was the MapReduce who was doing that. It was doing playing a dual role. doing a resource management as well as the data processing. And Jan came into picture and said, man, you are good with the data processing. Why don't you do that? Let the resource management be handled by me. Fine. Before that happened, what was the challenge? Because without the challenge, there is no innovations. So we're going to discuss that, okay? So before we get into detail, we know this architecture, right? We know that master, master nodes, and then you have a slave nodes. And when we talk about the HDFS architecture, you have a name node, and then on top of name node, basically with the master, you have a job tracker. The job tracker is a name given to the master daemon within the Hadoop version 1. Okay, I'm giving you a differentiation between what the what are the both for. So HDFS layer is name node, daemon, master daemon, and the map reduce layer, because map reduce was the one which was handling the doing the dual role, cluster management as well as data processing. So daemon was known as a job tracker. Fine, fair enough. And the name node is the one which used to interact with the data node, which is a slave for HDFS. And what is a slave daemon for the job tracker? Is a task tracker. Fine. So you have the differentiator between the both the map reduce layer daemon and the HDFS layer daemon for the slave. Okay, clear? Now what does the job tracker does? Multiple times we have been repeating that job tracker is the one which used to do dual roles, basically resource management as well as data processing itself. Clear? And the task tracker is the one who is responsible with the slots. Now I mentioned about the slots. Let me come back to the slots and discuss in detail, because that is where the main pain points are. Okay, and we're going to discuss about the pain points as well. Before that, let's go to a case study. What will happen is there's a client who have requested the map reduce job. So once the map reduce job has been requested, the request actually goes to the job tracker. Fine. The job tracker is the one which goes and talk to name node. So they work hand to hand. Fine. Because name node is the one which is rack aware. Fine. It knows which data block is sitting in which node, which data node, so and so forth. The HDFS architecture, and that information or the metadata information has been given back to job tracker. Based on the information that the job tracker has received from the name node, it goes and it basically makes its judgment and identify the proper task tracker. Let's say in this case, this task tracker, because the data node is sitting here residing. So it has decided to send the information to this task tracker. The task tracker actually is holding some kind of slots. It is the one who manages slots. Fine. But these slots are predefined. There is a file called mapred-site.xml, and that is where you have the two parameters, the map and reduce parameter, and you actually pre-configure the slots accordingly. So you will give the how many number of map slots should be there per task tracker, and how many number of reduce slots should be there. So it's a predefined. So note the point, it is predefined. So there's a catch there. Now before it comes to task tracker, I forgot to mention a point over here. Somewhere here, right, there is a segregation of the job. So the job is basically converted into task. What kind of task? The map task and the reduce task. So somewhere here it has been segregated, and that is what the task has been sent to the task tracker. So it has a clear understanding what is a map and what is a reduce task. And it also have its predefined slots for the map and the reduce slots. So it actually process the data in its respective slots, the map and the slot. Fine. So when we talk about the slot, there are few pain points there. The slot basically goes waste anytime when the cluster workload is not is over and the static configuration is not compatible. So that is where the slot goes waste. So that is one point. And the second is basically the slot based model makes it hard for the non-map reduce application to be scheduled appropriately. So that is second point. And the third is job never leaves the original slot and cannot move to the freed slot. So there are slots are rigid, so they are kind of restrictions, and that's a big pain points. And scheduling also was a pain point. Anyways, so once we understood the pain points, fine. Now what will happen is once it is processed the data. While processing the data, if you are coming from ETL background, you might appreciate that when you're dealing with data, there's a lot of issues, especially when you're processing the data. Because I'm coming from the ETL background, I know how much of pain when you write a ETL code and try to process it. There is always kind of issues. Maybe data quality issues, fine. So when let's say the job tracker encountered a record that is not appropriate, so it might fail, and that what happens, then it reports back to the job tracker. So job tracker would actually try to avoid that particular record, and so forth. It's a decision making, or maybe the job tracker itself has failed. Sometimes the ETL tool might go off the network, or maybe something goes wrong, because being a software it happens, right? So the task tracker may not process it. So if it is so, because task tracker also have a task within it to often report back its availability to job tracker, kind of heartbeat, right? If the job tracker doesn't hear back from the task tracker for a period of time, it assumes it's dead. That's one thing. Fine. So if that happens, job tracker will try and allocate the task to some other task tracker. Okay, fine. And then if the task tracker is completed, it will report back finally with all the hurdles or hiccups what it can come up with. If it has overcome all those hiccups, it actually finish with the process of the data, and it reports back to the job tracker, and job tracker will be reported back, and it is where the information will be stored, so that the client can pull information as and how it requires. So this was the whole architecture of the version 1. And we have understood the pain points, how rigid the architecture was, and moreover, in the introduction we have understood also that the reason for Hadoop version 1 coming into existence is because in 2012 Yahoo hit the roadblock of not able to extend more than 4,000 nodes, and you might appreciate why it was not able to extend for more than 4,000 nodes, because of these all issues which the MapReduce was handling, the dual role, doing the data processing as well as the resource management, so on and so forth. So it had that kind of limitation. To overcome that limitation, the new architecture came into picture, and that is how the birth of Yarn was established. Now we're going to discuss about the Yarn architecture. Before we get on to the details understanding of Yarn architecture, I wanted you to be getting familiar with the few terminologies, likewise the resource manager, which is being a master daemon within the Yarn architecture. And when we have the master daemon, we also need to have a slave daemon, right? So it's a node manager. This is something which we have already discussed in our previous slides. But addition to that, there is one more term that need to be understood, is the application master. Okay, application master. And second, one other thing which I wanted you to get familiar, which is going to come on the slide, is the containers. Fine. The containers is is the same like slots, but they are more flexible. How they are, we're going to discuss that in detail. Now coming and discussing about the each components in the yarn architecture. So resource manager, what does it do? The name, as the name suggests, it is the one which allocates the resource. Fine. And you have to bear in mind the main purpose of yarn is to cluster resource management. It is the one which actually manages the resources. And addition to that, it also, we said earlier, right? It also schedules basically. It also schedules. So it has the capability of scheduling the jobs. And when we talk about the scheduler in this architecture, just trying to emphasize here one point, that it is a pure scheduler. What does it mean? I.e., it does not monitor the schedule, it does not actually restart the schedule, it does not does anything, it is a purely a scheduler. Hope that is all clear. Now coming to the second point is application manager. Note, it is not a master, it is a manager. Fine. So what does it do? Obviously, as the name suggests, it's an application manager. So the application masters, which basically are allocated for each application. What does it mean? Application can be understood as a client process. Each client process can be considered to be an application within the architecture of yarn. If you are from Oracle background and if you understand the Oracle architecture, there is the concept of PGA, Program Global Area. The way the PGA works, when the client request comes, when the SQL query request comes, for a dedicated client, right? So for a dedicated client, your PGA has been allocated within the SGA, System Global Area. Fine. And the moment the client connection goes off, the PGA is also flashed out. Similarly, similar kind of aspect is what the application manager is playing over here. The same kind of similar role, almost the similar role. Okay. So each client, each application manager. Fine. For application master. Application master is for an application. That means for each client. Clear? Now, and what application manager does it? It is the one who manages all the application masters, whether it's one application, two applications, or three applications, a number of applications. Right? It is the one who manages that. I.e., it is the one who is responsible for monitoring it. It is the one who is responsible for restarting of the application master in case of its failure, so on and so forth. Clear? Fine. Going forward, node manager. When we talk about the node manager is the one who actually owns this container. Now, what is a container? Container is to be simply understood as a resource, allocated resource. Fine, for that particular node and for that particular application master. It is like simple RAM and the vCore that has been assigned for that container. Okay, and it is flexible. It is not, and it can be actually compared, or it can be understood as a slot as well. But slots in the previous architecture were rigid. Fine, map had its own rigid fixed number of slots, and the reduce had its fixed number of slots. But this is dynamic. So the containers are created dynamically and they are flexible. Fair enough? Okay, and they are the one which owns by the node manager. And when the node manager is the one which is owning the container, that means it is the one who monitors its resources. Okay, it's the one who's basically monitoring the way it is working, and it's the way it's utilizing and processing the data. The other thing which node manager does is basically it monitors, it takes the health check of the node itself. Fine. And the third thing that it does is it report back the information or the availability of the node manager or the complete node to the resource manager. So the resource manager is quite aware of the available node manager, and so on and so forth. Hope that's all clear with that. Now getting into the scenario, now we have discussed about the application master. and the application master is for each client. So that's the reason you might see that the color coding that I have given is one application master is for one client. Okay, so you will have two clients here in this case, just for the clarity, that gives a request, and that is where the job is converted into task, map and reduce, and the resource manager is the one which basically is the one which instructs the application master, which kicks off this application masters. Fine. So the application masters are kicked off. So one application master for one application, whole application. So that is client. How many requests, how many job the client request, doesn't matter. It is one application master for one client. Very simple. Fine. The containers are the one which runs the actual map reduce jobs. Okay, in collaboration with the node manager. Okay, and node manager is the one who monitors and manages the containers. Fine. So what will happen is if there is any resource negotiation that need to be happening, right? It is the application master which directly interacts with this resource manager. Right, and then it is the one which allocates the resources to the application master. Okay, and application master also, in collaboration with the scheduler, it negotiates the memory and the resources for the container. Fine, fair enough. So that's all the information that we have about the application master to be understood. So application master is the one which also negotiates the resources from the resource manager. And what will happen is, as and how the jobs are executed by the client, multiple jobs, doesn't matter. So in this case, the client one have multiple jobs. So all this, the green arrow is the status of map reduce, which is running within the container. Okay, so these are the green arrows which are reported. So one application master for multiple containers, that means multiple requests from the one application, one client. And similarly, the same thing over here, one container for the one application master, multiple container for one application master, and that is reporting this slides. Just for the clarification, I have given this legend here. So the arrow, what does it mean here is the job request, this is what the job request is, and the map reduce status, whether the map reduce is completed or not, is in green. Okay, and then the node status, which is this arrows, which is the node manager giving to the resource manager, and the resource request. So the application master, which is requesting the resources from the resource manager. So this is how the architecture of YARN works altogether. Hope that all makes sense. Now replaying what exactly we discussed. So simply the this will be a collaborative information of how the HDFS architecture and the YARN architecture works very quickly. Yeah, quick glance. The client basically goes and interact with the name node, and you know what is a secondary name node. We have already discussed. It's not a replacement for the name node. It is just managing the edit log and the FS image, the namespace for the node manager. So it's an extra hand for the name node basically. Okay, and then the client also can interact with the resource manager. The resource manager is the one which basically interacts with the name node for getting the metadata. Fine. It is the one which interacts with the name node for getting all the metadata and so on and so forth. And secondary thing is the slaves. So for the resource manager, you have a node manager, and they interact. The resource manager interacts with the node manager and manage the node in a nutshell, and the name node basically manage the data nodes. Fine. So this is all about the YARN architecture. Hope this all made sense to you. If that is so, please do subscribe to us. Thank you very much.